Hello everyone, welcome back to the channel and you are watching Komal Taya. Right guys, so in today's video, I'm going to talk about a previous year question which is very important from examination point of view, and that question, that is statement wise question, and I'm laying emphasis on that question since so many videos, right? So that question is seriously very important, and that becomes more important when it gets combined with first order perturbation, right? So when examiner gives that question, so that question should be regarding second order perturbation because I'm teaching you second order perturbation. But what examiner does, that he combines that question with first order perturbation, and in one question only he checks almost your basics and the concept, because second order perturbation, first order perturbation, they are very small topic, right, in our syllabus, right? So what will happen, he'll try to check your concepts, and from that he can check your concept by giving statement wise question, right? So let's just see what that question looks like, right? So everyone just pay attention over screen. So this question looks like this. So I'm talking about this first question. So what is given according to this? A particle of mass m is confined in potential well given by Vx is equal to 0 for minus L2, and this x is varying between minus L by 2 to L by 2. So okay, a potential well is given and that is varying between minus L by 2 to plus L by 2, and Vx infinite elsewhere, like it is inside it is 0, inside the potential well it is 0, and you know the potential is infinite elsewhere. Clear? So now a perturbing potential hx is equal to alpha x. So now perturbation is given, and that perturbation has been given in terms of alpha x. Clear? So that has been applied to the system. So now the system is perturbed, and now let the first and second order correction to the ground state be this. So first order correction to the ground state is this, and second order correction to the ground state is this respectively. Fine. So which one of the following statement is correct? Clear? So we need to find which of the following statement is correct. So okay, this is first order partition, and you know 0 is given, so that means 0 is the ground state. Clear? And this is the order. So this is first order correction and this is the second order correction. Clear? And this question has been in just 2015, but similar type of question is several times I have seen that in previous year question of CSIR chemistry only. So just pay attention over this question. This question is very important. Clear? So now we need to tell that which statement is correct. So according to first, so it is less than or greater than or less than, equal to 0 or greater than, equal to 0 or less than. It is about first order perturbation and second order perturbation. So first of all, let me tell you, I told you one thing, that the second order perturbation, please always remember, second order perturbation, second order correction basically, fine, second order correction, fine, in the ground state will always be negative. Fine. So if I write it in terms of this, del E 0 2, it will always be negative. That means less than 0. Fine. So now I'll see those options where del 0 2 is negative. So in which cases it's 2, it is 2 2 2. So let's see in which cases it is negative. So here it is greater than 0, it is incorrect. Again it is greater than 0, it is incorrect. So the only option we are left with, that is third option and the fourth option. Clear? So either it can be this one, third one, or it can be this one. Clear? So let's see what can happen. Fine. So what can happen? So let's see. So I'm just telling you the solution over here. Clear? So now we need to find over here. So already perturbation has been given, that is alpha x. Clear? So you know that if you need to find, now we are sure about second order perturbation, that would be negative, that would be less than 0. We don't know about the first order perturbation. Fine. So the first order perturbation, you know the formula for first order correction, that would be this one. You know, if you need to find first order correction, that would be psi, whatever is given, that is 0, and this 0 obviously del h, and then psi again 0 and 0, and it would be d tau. Fine. So now it is one dimensional potential well, so it is d tau will be replaced by dx. Fine. So that's what I have written over here. That's what I have written over here. So you can see psi ground state or 0, whatever you write over here. And this is del h. You know del h is already given in the question. That is alpha x. Fine. So I have written over here alpha x and then psi ground state and dx. Clear? So now what I'll do. So guys, you know that this alpha is constant, so I'm taking it outside. So this becomes, I'm writing it over here. So this becomes alpha, and now psi naught and x, psi naught and dx. And you know that what it becomes. If you have to write the average value of A, suppose, take anything, A, B, C, D, I'm just telling you anything. Suppose if you have to write potential value of this kinetic energy, average value of kinetic energy. So you'll always write like this, psi, fine, and this kinetic energy, and then psi and d tau, fine, this operator. Clear? So that's what we can always write like this, and we can write it like this also. Clear? So now I can replace this whole term with this, because this is psi naught x, psi naught dx. I can write it like this. That means the average value, because the average value formula of x displacement would be psi naught x, psi naught dx. Clear? I'm just replacing it with this thing. Clear, guys? I hope that thing is clear to you. If you have any doubt, please use the comment section and just ask me whatever doubt you are having, even if it is very small one, right? So that is alpha and the average value of x. And you know the x value. So always remember the average value of x and the average value of linear momentum for SHO, for simple for potential box, for potential well or simple harmonic oscillator, that is 0. That is 0. Clear? So now this average value is this x, that is 0. So when I'll multiply alpha into 0, so that would become 0. Clear? So that would become 0. So here the first order correction to the system, to the potential well, that becomes 0. So I'll write this E01 is equal to 0, but E02, you know that for ground state second order correction, it will be always be negative. So that would be always less than 0. So now let's see which option it fits in. So I guess it fits in this one, in D option, right? So it fits in D option, and D option is correct. Fine. This is less than 0 and this is equal to 0. So D option is the correct option. Fine. And you get directly 4 marks. But guys, this time this alpha x has been given in the question. Fine. So in the coming videos, I'll be talking about that question, where I have to tell. In the theory also I discussed that I'll tell about, like, we know that the second order correction in the ground state, that is negative. I didn't tell you about the first order correction, like what it will be. It will be positive, 0, negative, what it will be. We don't know. That I'll be telling you in the next video. Fine. So don't miss it. That is very important. Examiner plays there only, because that is a little bit confusing, right? So examiner plays there only, and I'll tell you the example, like the previous year question only, and I'll show you that how examiner tried to trick you all. Fine. So people who were appearing at that time only, right? So just for now, I guess, and this is the thing, and this is the answer. So if you have any doubt, please leave it in the comment section. Please tell me. I'll be happy to entertain your doubts. And that's it for this question. Clear? In the next video, I'm going to take another previous year question of second order perturbation only.